All right, everyone, let's go over part number 3. I'm just going to do number 1 and walk you through all of those steps. So we're given this polynomial, x to the 4th minus x cubed minus 5x squared plus 3x plus 6. So to sketch a graph, I'm just going to plug that into Desmos or plug it into my graphing calculator so that I can get an idea of what that looks like. And so when I do that, I see that I've got two really nice intercepts at a -1 and at a +2. And I can't exactly tell where the other guys are, but this guy goes down through here, it comes back up, it goes down, and it goes back up. So I really only care about this x scale so that I can see where your intercepts are. So we've got one guy here, a mystery guy here, one guy here, and another mystery here. So our x-intercepts, the ones that we know for sure, are going to be x equals 1, oops, -1, and x equals 2. And there are 2 more, but we don't necessarily need those at this point. So since one of our x-intercepts is +2, that means x minus 2 is a factor. Create a Polydoku to divide our polynomial by that factor. So I'm going to write that x minus 2 over here on this side. And I'm going to write my original polynomial down here, right? When I'm dividing, I have an answer, and I'm dividing by a factor to find the other factor. And so I know that my constant 6 is going to go on that left line here of my last box. I've got a plus 3x. We have the minus 5x squared, the negative x cubed, and the x to the 4th. So I always start with my first and my last because those guys have no other like terms. So I know my constant, my last term, is going to go in my last box here, and my x to the 4th is going to go in my first box here. Let's make that actually look like a 4. And now we're going to fill out this top here. So x times what gets me x to the 4th? That would be x cubed. -2 times x cubed is a -2x cubed. Now looking at this diagonal box here, I want a -x cubed. I have -2x cubed. So what has to go here is going to be a +1x cubed, right? Because these two added together will result in that -x cubed. So now I can figure out what goes up here. X times what gets me this, and that's going to be a +x squared. And I can fill out my result here, which is a -2x squared. Now my diagonals have to add to a -5x squared, which means I need a -3x squared here. And then what goes up here to get that times the x will be a -3x. And I can fill out my result down here, which is a +6x. And I want a +3x. So from the 6, I'm going to have to subtract 3x. And then to get this with the x over here, I need a -3. And then just double check that it does get my constant. A -2 times a -3 does get me that 6. And so now we can rewrite the product of our linear factor, which is our x minus 2 over here, and the cubic factor, which is what we just found, right? The cubic factor, because my highest degree is a 3, which makes this a cubic function. And so I'm going to write that x cubed plus x squared minus 3x minus 3. So our first Polydoku is done. Now we have another x-intercept. I'm going to divide the result from my previous, so that is this guy here, by this other factor. So my linear factor, again, is that x plus 1. And my results, I'm going to write down at the bottom. So this guy is going down at the bottom. I've got a -3 on the left line of my last box, a -3x, a +x squared, and an x cubed out here. So again, starting with my first and my last, oops. So x cubed will go in this box, -3 in this box, and then we can work from there. So x times what gets me x cubed? This would be x squared. I would get an x squared here. And I want an x squared, which means I don't need anything in this box. X times what gets me 0? It has to be 0, which means this box is also 0. And since I want a negative 3x, that means that this diagonal has to add to negative 3x. And so that's exactly what I need here, which means a negative 3 will go here. And then just double check, negative 3 times a positive 1 does get me that negative 3. All right, so now we're rewriting what we just did. Our linear factors, which from before, we still have that same factor, that x minus 2 is still a factor. And then this x plus 1 is our other factor, other linear factor. And then you just found the quadratic factor, this guy here, x squared minus 3. We don't have to write the 0 if we don't want to. So now we've got the quadratic factor. That's how I know I am done dividing. Once I have an equation with a degree of 2, I don't need to do any more Polydokus. Now solving for all the roots, right? We already found 2 of them. We already knew from our linear factors that we had an x equals a positive 2 and an x equals negative 1. But now we need to solve for this guy. So essentially we're just doing zero product property here. If I said this whole equation equal to 0, that means I'm setting each part equal to 0, right? So x minus 2 equals 0 means x has to equal 2. X plus 1 equals 0 means x has to equal negative 1. And so we'll do x squared minus 3 has to equal 0. And now we'll just solve. We don't need to factor or do quadratic formula since I can easily isolate the x squared and there won't be any other x's to deal with. And now remember, when you take the square root, when you undo a square, you will always have a plus or minus answer. So my other x values is a positive square root of 3 and a negative square root of 3. And there is all 4.